Okay students, now let's go for the second application of potentiometer. The next use of potentiometer is used to find out the internal resistance of a cell. Potentiometer is used to find out the internal resistance of a cell. Okay, for saying that, let me draw the circuit diagram. We will have to draw our potentiometer wire. This is our potentiometer wire, and let's call this point as A and this point as B. We will complete our primary circuit, which is similar to our previous diagrams. We will complete our primary circuit, that is, it should have a cell. Positive terminal is connected to A. From the negative terminal, we will be connecting it to a rheostat. After rheostat, we will be having a key, and from the key, we will complete the circuit at B. Primary circuit is over. And in the secondary circuit, we are taking a wire, and the cell whose internal resistance is to be connected over here. The cell whose internal resistance that is to be found out, it should be connected over here, and it is important that from A point or from the point A, the primary cells positive and secondary cells positive, it should be connected. In all the potentiometer diagrams, from the A point, it should be connected to the cells positive terminal. Okay, therefore positive terminal, and from this we will be connecting to a galvanometer and then to a jockey. Then you may wonder what's the difference from the first diagram and this diagram. There's no difference actually. But now I'm going to add an additional circuit over here, that is, we are connecting a non-resistor. It should be a resistance box in your experiment. It should be a resistor box. I'll say it's a non-resistor of R, and there is a key also. Then we are connecting it like this, that is, a non-resistor with the key. It is connected parallel to the cell whose EMF is E and internal resistance is small r, and it is to be determined. Okay, then this is the circuit diagram for finding out the internal resistance of a cell. This is the circuit diagram required for finding out the internal resistance of a cell. Then let's find out the internal resistance of the cell. For finding out the internal resistance of the cell, initially we will unplug this key. That is, initially the circuit is like this. If the circuit is like this, means there is no connection over here. Therefore, it is similar to this connection. You could compare these two. If this circuit, the red color circuit is not there, it is like this, then we will proceed. We will proceed in the similar manner, that is, we will obtain the balance length. We will be scrolling this jockey through the potentiometer wire until we get the galvanometer deflection 0, or we will obtain the balance length. And that balancing length should be directly proportional to EMF. Therefore, EMF directly proportional to balance length. Let me call this balance length as L1. What are the balance length? L1. After performing this, we will connect the key over here. We will plug the key over here. Therefore, this resistive circuit will be also there in our combined circuit. അങ്ങനെയാണെങ്കിൽ നമ്മൾ ഈ റെസിസ്റ്ററിനെയും കൂടി പ്ലഗ് ചെയ്യുമ്പോഴുള്ള വ്യത്യാസം എന്താണെന്നാൽ, അപ്പൊ ഈ റെസിസ്റ്ററിനുള്ളിൽ കൂടിയും കറണ്ട് പാസ് ചെയ്യും. ഈ റെസിസ്റ്ററിനുള്ളിൽ കൂടെ there will be a current pass. എന്തെങ്കിലും ഒരു കറണ്ട് പാസ് ചെയ്യും അല്ലെ? അങ്ങനെയാണെങ്കിൽ റെസിസ്റ്ററിനുള്ളിൽ കൂടെ കറണ്ട് ഇപ്പൊ സാധാരണ രീതിയിൽ പാസ് ചെയ്യും. ഇനി ജോക്കി ഇങ്ങനെ ഡിഫ്ലക്ട് ചെയ്യുന്ന സമയത്ത് ഈ കറണ്ടും സീറോ ആവും. ഈ കറണ്ട് സീറോ എന്ന് പറഞ്ഞാൽ ഇതിലൂടെയുള്ള കറണ്ട് പോയിട്ട്. അപ്പം അങ്ങനെയാണെങ്കിൽ ഈ ടെർമിനലിന് അക്രോസ് ആയിട്ടുള്ള പൊട്ടൻഷ്യൽ ഡിഫറൻസ് വി ആണെങ്കിൽ അത് തന്നെയായിരിക്കും ഇവിടെയുള്ള പൊട്ടൻഷ്യൽ ഡിഫറൻസും. കാരണം ഇവിടെ നമുക്ക് എന്ത് ചെയ്യുന്നുണ്ട്, പാരലൽ കോമ്പിനേഷൻ ആണ്. അപ്പം ഈ രണ്ട് ടെർമിനൽസിന് അക്രോസ് ചെയ്ത പൊട്ടൻഷ്യൽ ഡിഫറൻസിനെ, ഈ ടെർമിനൽ അക്രോസ് ആയിട്ടുള്ള പൊട്ടൻഷ്യൽ ഡിഫറൻസ്, ആ പൊട്ടൻഷ്യൽ ഡിഫറൻസിന് അക്രോസ് ആയിട്ടുള്ള ബാലൻസ് ലെങ്ത് ആണ് നമ്മൾ കീ പ്ലഗ് ചെയ്യുമ്പോൾ കിട്ടുക. Therefore, if you are plugging the key in, the resistor is part of the circuit and there will be a potential difference developed across the resistor. That potential difference will be equal to the potential difference across the E and the cell. Therefore, the second case balance length will be proportional to the voltage. Potential difference in across balance length L2. Okay. Therefore, എന്താ നമ്മൾ ചെയ്യേണ്ടത് ആദ്യം ഈ കീ അൺപ്ലഗ് ചെയ്ത് വെച്ചിട്ട് നമ്മൾ EMF-ന് കറസ്പോണ്ടിങ് ആയുള്ള ബാലൻസ് ലെങ്ത് എടുക്കും. രണ്ടാമത് കീ പ്ലഗ് ചെയ്തിട്ട് വോൾട്ടേജിന് കറസ്പോണ്ടിങ് ആയുള്ള ബാലൻസ് ലെങ്ത് എടുക്കും. ഇപ്പൊ രണ്ട് ബാലൻസ് ലെങ്ത് കണ്ടുപിടിച്ചു. Therefore, I could write E by V is equal to L1 by L2. E by V equal to L1 by L2. ഇനി let us recall the expression for EMF. Let's recall the expression for EMF, that is, we know EMF is equal to I into R plus R. EMF is equal to I into R plus R. പഠിച്ചിട്ടുണ്ടല്ലേ? V is equal to IR എന്നും പഠിച്ചിട്ടുണ്ട്. അങ്ങനെയാണെങ്കിൽ let's use that over here. ഇവിടെ നമ്മൾ ഇത് യൂസ് ചെയ്യുകയാണെങ്കിൽ നമുക്ക് let me write, we know V is equal to IR. പഠിച്ചിട്ടില്ലേ? ഉണ്ട്. And we have also learned EMF is equal to I into R plus R. പഠിച്ചിട്ടുണ്ട്. Therefore, let's substitute for E and V. Then it will be I into R plus R divided by IR. It should be equal to L1 by L2. Then we could cancel this I and I. Then we will be R plus R divided by R. That is 1 plus small r by capital R is equal to L1 by L2. Then small r by capital R is equal to L1 by L2 minus 1, from which I could write small r is equal to capital R into L1 by L2 minus 1. Small r is equal to capital R into L1 by L2 minus 1. This is the formula for finding out the internal resistance of the cell. This cell in the internal resistance formula. What is capital R? Capital R is the external resistance which is there in the resistance box. This resistance box is external resistance. Resistance. L1 is the balance length. L2 is the balance length. L1 is the balance length corresponding to EMF. That is key unplug key unplug balance length L1. And L2 is the balance length corresponding to voltage. Key plug voltage potential difference in across develop the balance length. Therefore, capital R is equal to small r is equal to capital R into L1 by L2 minus 1. This is the expression for finding out the internal resistance of the cell by using potentiometer. Potentiometer two tasks. One is to compare the EMF between two cells. In order to compare the EMF between two cells, this is our circuit diagram, this is the equation. In order to find out the EMF of two cells, this is the circuit diagram and this is the equation for it. And what's the basic principle of a potentiometer? Basic principle of a potentiometer is EMF is directly proportional to balance length. The basic principle of a potentiometer is EMF is directly proportional to balance length. What is balance length? The length from A to the jockey where galvanometer shows zero deflection. Galvanometer zero deflection A il nunnu jockey lekku dooramanu balance length. Okay, clear.